So, here we go. First thing is, I think I said this before, but I say it again. When students saw this, some of them got, freaked themselves out, and they bailed on the problem when I honestly had kids take a 9 when if they just read past this, they at least said, eventually it said, find three terms for cosine. Holy cow, even if you don't know what the heck they're doing out there, plow on and say, geez, at least I could do that. You'll get there, you know? Okay? If you don't know the series for cosine, then you should quit, because you are ridiculous. All right, would you agree that the series for cosine is that, and the general term is that?
Yes.
Okay, and it does, that factorial does have to have parentheses around it, because otherwise it's too tangential. Okay? Also, would you, if you don't have dot, dot, dot at the end of that, would you put it there, please? So many people are ending at the general term. It doesn't end ever. It goes forever after as well. All right, now, it depends on you how you build from there, but wouldn't you agree that I need to build all this other stuff? I did it in 2 steps. You could do it in 1. I subtracted 1. Now, when I subtract 1 from the left, I subtract 1 from the right. When I subtract 1 from the right, that goes away. And it's negative x squared over 2 factorial plus x to the 4th over 4 factorial. But now I guess I'll need to put another term because I just lost 1 to have 3. That does not in any way change even. Now, a little bit of an issue. You start getting at such a high level that you don't know how to subtract. I had a question in the last class that said, do I subtract 1 from every term or just subtract 1 once? Well, take this, okay? Got it? Now, if I said subtract 1 from that, do you subtract 1 from everything or you just subtract 1 once?
Everyone.
Subtract 1 once, right? Don't overthink, okay? You're not subtracting 1 everywhere, which would mean you subtracted 1 over here and infinite over here, which is not balanced in any way. You subtracted 1 from each side, all right? It does not change the general term when you do that. It's the same. Cosine of x minus 1 divided by x squared then means I'm going to reduce every one of those by x squared, right? This then is 1, negative 1 over 2 factorial, which, hey, looky there, is f at 0. I didn't need to build that or write that. It made itself because it just came out in subtracting and dividing by x squared. This is x squared over 4 factorial. This is x minus x to the, be ashamed to miss a point because you changed a sign from one step to the other. X to the 4th over 6 factorial. The general. There's 2 schools of thought here. Depending on your teacher, they might tell you how to find the general term one of 2 ways. I was taught to just take the general term you had and say, what did you do to it? I didn't change that. I didn't change that. What changed is I took 2 away, 2 x's away, so it changed to x to the 2n minus 2. Now that is one possible general term. Another school of thought is to say, look at the pattern you made and write the pattern. Now they say, hey, look at the exponents. They're x to the 2n. And the denominator is 2 more than that. And the negative would have to be, well, to start off negative, and considering I'm starting at 0, it would be n plus 1. That's another possible general. They have a different starting n value, but they're both fine. All right, so you have to figure out if yours is equivalent to one of those 2, or it could even be something totally different. But there you go. Are you with me? Are you with me? So then the question is, what about this? Well, what about this? The limit as x goes to 0 of cosine of x minus 1 over x squared. Isn't that 0 over 0? And that's an indeterminate form. And so if I were to use L'Hopital, wouldn't the limit as x goes to 0 be negative 1/2? So this graph was getting a hole at x equals 0, and what did that do? It filled the hole. Okay, so it's continuous, that's all. That's all you're using, you never use it again, doesn't matter ever again. Doesn't even matter if you understand it. Yes?
Is it two locals that you have to use, or just the one?
Yeah, I guess two eventually, but eventually, yeah, you're right, sorry, but eventually.
Okay.
Yeah, sorry, good point. You're right, this is, you're right, sorry, negative cosine of 2 minutes.
Sorry.
No, I appreciate it, sorry, I was going too fast. All right, you with me? Okay, B, there are also two ways to go about B. Usually students do it one way and I do it the other. How did you do B? Actually, let me tell you what absolutely won't work. And that is, students say, use the Taylor series. No, I don't like that. I'm going to find a relative maximum of f, and they just say, I'm going to do it like a Calc 1 problem and maximum that B. Is that okay?
No.
No, that in no way answers the question. It is not okay. You can't just pretend they didn't say use the Taylor series. They said use the Taylor series. So what's one way to talk min or max? Okay, so one is to look at the terms, and use term knowledge. Now that's how I do it. And that would be something like, well, I know based on the general Taylor idea is any x to the nth term comes from the nth derivative over n factorial, right? So if I wanted to talk about the first derivative at 0, wouldn't that mean I focused in on the Taylor where I see x to the first in the x, right? If I look here, I see there is no x to the first. Well, what does that imply? F prime at 0 must be 0. Okay. Now I could do the same then, rather than do a ratio or a sign test on either side, which I don't want to do. Too complicated. Second derivative at 0 should be tied to where I see a 2x squared. Now, definitely don't fall into the trap of thinking, oh, so I should look for the second derivative where I see 2 factorial. That is not the case. The factorial means nothing. It can change. There could be a million things done to the factorial. Ignore the factorial. Look here. If you want to find f double, then find x squared. That's what tells you f double is going on. So if you want to make a determination about f double, look there. It looks like it's equivalent to x squared over 4 factorial. If I dump the x squared, still focusing on the numbers, doesn't that seem to mean that f double is 2 factorial over 4 factorial? Which I suppose I'm really just interested in the sign. That's 1/12 if I like. But does that tell me something then? What does that tell me about the extremity? It's flat with concave up, and therefore a relative min. So you should say something like f has a relative, the test uses both words, so local or relative, either one. Local min at x equal 0 because f double is positive and f prime is 0. You need both. Okay, that's one way to do part B. Another way to do part B is to say, well, if f is equal to this, then, and that's equal to this series, then couldn't I take derivatives on my series? What's the series for f prime? Nothing plus 2x over 4 factorial minus 4x cubed over 6 factorial and so on. So what about f prime at 0? What is it? 0. Okay. Now what about f double? If I took the second derivative on the series, well, the second derivative is 2 over 4 factorial times 1 minus 4 times 3x squared over 6 factorial. F double at 0 is 2 over 4 factorial. That's positive. You could do it that way. You with me? Does one of those ways make sense to you? Cool. Okay. C. Write the fifth degree Taylor for G. Okay, G's cooking me out. So G is 1 plus 0 to x of f. I'm supposed to go series, so where do I go from G? What do I do now? Plug it in. Plug in the series for f. I just determined that the series for f is, now they would read with you, so if you made like some kind of goofy sign error in that, like you switched to negative or something, you would lose a point in B, obviously, but you would still be in for G, all right? So they would read with you and go with what you have. All right, so when I plug this series in, do I plug in with x's or t's? Look at the word. It's f of, in the integral, it's t, right? So it should be t squared over 4 factorial minus t to the 4th over 6 factorial. I don't know, should I go through the general? How far should I go? Through the 4th? Why? Yeah, so what does that have to do with the 4th? After I integrate, the 4th degree will become the 5th degree. So that's why I only have to go through the 4th degree, because after integrating, that'll get me 5th degree. When I go to integrate that, I did this in one step. I don't know if it would have cost me. I integrated and put in x. I guess if I really wanted to play it safe, I would have said the antiderivative of this is negative 1 over 2 factorial t plus t cubed over 3 times 4 factorial minus t to the 5th over 5 times 6 factorial, and then put in x in another step. I don't know if it would have cost me. I think it would have been fine. But you never know. So negative. So do you have something like 1 minus 1 over 2 factorial x plus x cubed over 3 times 4 factorial minus x to the 5th over 5 times 6 factorial for an extra. All right, I haven't been talking points. Do you want to go back and talk points, or do it at the very end? At the end, okay. D then, are you ready for D? D is Taylor series for G, centered about x equals 0. I did that. Evaluated at x equal 1 is an alternating series. So the first thing I do is say, all right, I think I'm supposed to put 1 into my series. So if I put 1 into my series, it becomes a numerical series, 1 minus 1 over 2 factorial plus 1 over 3 times 4 factorial minus 1 over 5 times 6 factorial, cha-cha-cha. Okay, I got you. So it says use the 3rd degree Taylor to evaluate G at 1. So G at 1, if I use through the 3rd degree, isn't that through there, yeah? Do you agree? So if you add through there, did you get something like just 72 or something in there? I can't remember. 37 over 72. That's your estimate. Okay, now let's talk, explain why this estimate differs from the actual value by less than 1 over 6 factorial. So what are we thinking? Did you, first of all, did you write, I'm just curious, did you say G of 1 minus that estimate is less than, or did you say S minus S something is less than, or what did you do? Second one or the first one? Whatever, I don't care, they're both right. So what is it, S2, S3? S3, 1, 2, 3 terms. Is it alternating or Lagrange? It's alternating, so we're going to alternating. S minus S3, do I need to meet the conditions for error bound, or are they already met? They're already met, they're already stated for us. So S minus S3 is less than or equal to the absolute value of A4.
Pardon this interruption. At this time, please release student council members to the gym as well as marching band. Again, student council only and marching band only. Thank you.
Yes, sir.
Okay, you put like S3 minus G of 1.
Yes, any combination of or even this, T3, any combination of one of these for the real and one of these for the estimate, yeah, in any order also because they absolute value. Is less than or equal to A4, absolute value, which is 1 over 5 times 6 factorial. I think you'll agree that that's 1/5 of 1 over 6 factorial, so that's definitely less than 1 over 6 factorial. I did not evaluate because I felt like that was obvious to a reasonably intelligent calculus person. I think they could agree that's true. Okay. All right, so in terms of points, here is the breakdown. If you have the series for cosine, that's 1. That's a soft point. If you then, on this guy, there were 3 terms you should have done. If you have all 3 of those terms correct, that's 1 point. If you have the general term correct, one of the 2 forms I showed you, that's 1 point. So 3 points for part A. Here's something out of 3 for part A. Are you good? Okay. For part B, somewhere in your work did you claim that f prime at 0 is 0? That's 1 point. Then the second point was, did you say that there's a min at 0 with adequate reasoning? It had to be the derivative is 0 and the second derivative is positive for that. Yes?
Which work did you have to show for that?
For this, nothing. If you said nothing for that, if you just looked at the terms and pulled it, that would be fine. Obviously, this has to be stated. Yeah. Okay? And I will say this. I think you would have had to have evidence of why you say the second derivative is positive. If you just took a stab at it and said, I hope it's positive, that wouldn't do. You would have to have some kind of second derivative evidence, yeah, to justify that. Part C was 2 points. Yeah, 2 points. One was for any 2 of the terms correct, and one was for the other 2 terms correct. All right, so if you have any of those 2, you'd get 1 point. If you had the other 2 correct, so all 4 points, then all 4 correct, then you'd get 2 points. All right, but that was based on your original answer, or your answer. And then the last was, did you get an estimate of 37 to 70 seconds, or whatever would make sense based on what you had with carry-through error? If you had an earlier mistake, they would go with you. And then did you justify the error in S3 being A4 and show that that A4 is less than 1 over 6 factorial? That's the point. So it goes 3, 2, 2, 2. How'd you do? Did you drop a 9er on that? Yes? All right, now we're getting there. All right, we will, by the end of next week, I'm hoping we'll get to about half of us getting 9s regularly and the others getting 8s regularly. All right. Notes, finishing the notes from yesterday. I don't remember where in this class we left off. Part 2, 3.
We're still on the first.
We're still in section 1. Derivative doesn't exist, kind of thing.
Got to recognizing some limits.
Oh, got you. Did we do an example of that?
Yeah.
We did, like arc sine or something like that?
Yeah.
Okay, good. Okay, estimating a derivative from a table, the warning for this is, yes, change over an interval is a good estimate of how it's changing at a point, but it is an estimate. Please, I beg you, when you see on a free response question, approximate or estimate, would you please underline it when you get to it to remind you to say approximate. And that goes to when you're estimating a derivative, or you're estimating with the tangent line, or you're estimating area under a curve with the Riemann sum. Estimate, estimate, estimate. They grade based on whether you say it equals. It's not equal, it's an estimate, so be careful. All right, a derivative doesn't exist if, what are 3 reasons a derivative doesn't exist? It's not continuous, discontinuity. What else? Sharp turn. Sharp turn is a worst case scenario. There are some, like once every 5 years, you'll have to prove the derivative doesn't exist at a point. If, for example, if I give you this, question A said something like, use the definition of the derivative to show f prime at 0 doesn't exist, it would not be enough to say the limit as x goes to 0 from the left of f prime is 1, and that's not enough. That doesn't use the definition of the derivative. That uses derivative knowledge to be sure, but that would not be enough. If they say definition of the derivative, you would have to say something like, by alternate definition is what I would use. This is the alternate definition of the derivative, right? Now, if you use 0 and point to the left, then that means I'm using the function x plus 2. F at 0 is 2. Now, if you clean that up, the 2's drop out, the x's divide away. The derivative on the left is 1, which we knew to be true because it's linear, right? If I looked at what the slopes approach from the right, then it would look more like x squared plus 2 minus 2 over x. That's 2's drop out, 1x drops away, but then at 0, that goes to 0. You would then say 1 is not equal to 0. That's why a sharp turn is a no. It's because the one-sided limits, the slopes don't approach the same thing. That's what you would have to do. That's worst case scenario. That's pretty rare. You don't have to prove that usually. Getting back to this, not continuous, sharp turn, what's the last reason? That's discontinuous. Vertical, asymptote is also discontinuous. Try again, vertical, slope or tangent. Vertical tangent. Now that's a no because when the rise over run happens, the run is 0. Okay, so that's undefined. All right. Interpreting as a derivative as a rate of change. They will often ask you to interpret a derivative. Sometimes they will say, what is h prime of t? Generally, in which case you say it's the change in it's the rate at which the height changes, and blah, 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 blah. Sometimes they ask you to interpret a number. Now, if they ask you to interpret a number, if it's a number, then make sure you interpret the nature of the change or type of change. So for this problem, for example, it says the height of a tree as a function of time is given by that function, where time is in years and the height is in feet. Right? Prime and 3 they're giving you. Interpret this result in the context of the problem. They would always say using appropriate units. I forgot to put that. Okay? So would you interpret this answer, this result? So that means make reference to the number in your explanation. So I would start by using the 3. At time equal 3, what units? Years. The tree is, the height of the tree, sorry. The height of the tree is changing. Now you would have to be more specific and interpret the sign of the derivative. The derivative is positive, which means it's increasing. The height of the tree is increasing. Here's the key word for the whole sentence. If they don't see if you're interpreting a derivative and they don't see the word rate in there, you're out. Okay, that is a derivative. Increasing at a rate of 3.710 what units? Feet per year. That's I think that would cut it. But you want rate in there, okay? Notation, by far the thing you want to make sure is don't mix general with numeric. Here's what I mean. This is more of an amateur calc student, not you guys. But if I said f is sine of x, what is f prime at pi over 6? If somebody wrote this, oh, that's cosine of x, which is cosine of pi over 6, which is root 3 over 2. Good or bad calculus? Bad calculus. This is cosine generally, this is cosine specific, that's bad. The way we typically avoid that is an evaluation bar. You say, hey, that's the derivative, so you can check that I know that, and I'm about to put in pi over 6, then you okay? Derivative of a constant. Now I understand that, again, if I said, hey, what's the derivative of 5, nobody's going to miss that. I'm talking in the context of a more complicated problem. You go too fast, maybe, and you get so on your game with this side that when you take the derivative of this, you say, oh man, I made it to that product rule. Okay, this side is full. Ah, you forgot to take the derivative of the right side, okay? So when you take the derivative, especially an implicit, that happens a lot. And then to higher level students, okay? Slow yourself down a little and obviously take care on both sides to take the derivative properly, not just the complicated side. You with me? Are you with me?
Yes.
Are you having a good day?
Yes.
Okay. Okay. The power rule, again, I don't want to insult your intelligence, but there are mistakes made. Over application. If I say, what's the derivative of x to the fifth, is it true that it is 5x to the fourth? It is. That is the power rule. Don't overthink it. Okay? It is. Now, what I'm saying, though, is people over-apply it. Sometimes you might say, what's the derivative of 3, even, let's go, 3 to the x. And people might say, oh, so that's x comes down, drop it by 1. Yes or no? No. Not true. Okay. That power rule is applied to a numerical exponent. Only if the exponent is a number do you use the power rule, not a function. How do you do the derivative if there is a variable or a function in the exponent? What do you do? Use a what? Natural log. Use a natural log to bring down that exponent, and then you do some kind of product relation. Are you with me? There's no power rule when it's not a number up there. All right. Always simplify first. If you are, I think there's a problem on the back page that looks something like this: x over x minus 2 over x, or something like that. Well, I'm not going to do some kind of crazy quotient within a quotient rule. That's nuts. You would clean this up first and then roll. So maybe clear the fractions by multiplying by x over x, so you get x squared over what? X squared minus 2. Then quotient rule, chop, chop, chop. All right, you with me? Product rule. Again, this usually goes when there's always one person that they've been doing calculus for almost 2 years now, and then they start to just question everything, and they get this question, x squared cosine of x, and you know the first distractor, or one of the distractors, is going to be 2x negative sine of x. It'll be there. They make good distractors. They're meant to try and catch the knucklehead. Is that how product rule works? No, obviously not. No. Can you take the derivative of a sum individually? Don't overthink it. Yes, you can.
Yes.
Okay. The derivative of a product. Can you do those individually? No. Okay, so that's 100% no. Likewise, quotient rule. It's low d high, not starting high d low. It's low d high minus high d low over low, or over the square of what's below. Okay? Minus, not plus. There's always one person that uses plus. Chain rule, that's the derivative. Generally, we typically think of that as, hey, what happens when you have a function within a function? But remember, the heart of chain rule is really what happens when you do the derivative of something when there's an indirect relationship? So, for example, if, say, velocity depended on time and gas consumption depended on velocity, well, if I wanted to take the derivative of gas consumption with respect to time, then there would be this intermediate value. That's a chain rule. And in that case, I would think of it more like this kind of case. D gallons per velocity, dV dt equals, okay, that is truly the heart of the chain rule. I know that 90% of the cases we do more of a derivative of the inside, derivative of the outside kind of thing. But that's really what the chain rule started with. Okay? Implicit differentiation. Please pay attention when they say take the derivative with respect to blank. Read carefully. We made a lot of errors on this on an AP question on a test this semester. It said dB dt is, I don't even remember, negative 3b minus 50. And they asked for what is the second derivative. What are you taking the derivative of this with respect to? Respect to time again. So when I say, oh, this is negative, the second derivative, is it just negative 3 because the derivative of b is 1? No, that would be if I took the derivative of b with respect to b. They asked me to take the derivative of b with respect to t. So it's negative 3 dB dt. Obviously, you've got to pay close attention to the derivative with respect to what? Right? All right. Study and memorize. Let's talk exponential log. Some of these you absolutely know. Derivative of e is e, but do you know the derivative of a to the x? A to the x natural log of a, sorry. Yes. Okay? Now, if I didn't remember it, then I could always go off to the side and develop it. Well, I do know that I can't remember it, but I could take the log of both sides and deal with the old x and the exponent that way. And you could get there that way in no time flat. Okay? What about the derivative of natural log of x?
1 over x.
1 over x. Notice it's not 1 over the absolute value of x. People start to get integral rules and derivative rules confused. There's no absolute value. Okay? Now, if it was in here, that would still be okay. It's still 1 over x. What about the derivative of log base a of x? Remember it? Same deal. If you didn't remember it, you could say, well, I could always rearrange it. A to the y equals x. Take the natural log of both sides. Bring down the y. And get there eventually. Y is the log of x over the log of a. Take the derivative now. What is it? 1 over x natural log of a. Okay? Let's talk trig. I think you know sine and cosine. They're fine. At this point, you probably know tangent. If you don't, come on. What's the derivative of tangent? Secant squared. Derivative of cotangent? Negative cosecant squared. Derivative of secant? Secant tangent. Derivative of cosecant. Negative cosecant cotangent. The two arc or inverse trig, what's the derivative of arc sine? 1 minus, oh, that's, I put a u there, but I should have put an x. And arc tangent, you should also know. Okay. That's pretty good. There are a couple more. There are a couple more. Are we supposed to stay here?
Probably.
Maybe I should just keep going.
Nathan, they're out of here. Just forgot if they're going.
You what?
Nathan, they're out of here. Just forgot.
Oh, you're not going to the fun pep rally? I like pep rallies. I know you guys think they're lame, but I think they're fun. Community, you know. I'm all in community. All right. Oh, There's the orchestra, you better jump in. What's the band orchestra?
What, do you care if they turn things in K?
No, well, oh, sorry, this homework that you just picked up, that's not due tomorrow.
Oh.
That's crazy, that's,
Your son knew about it.
so reviews 1 and 2 and the Blue Series review, they're tomorrow.
Since I won't be here.
If you just, you know, or you want to just mark the questions on it, I'll try and okay, you bet. Are you waiting for me or are you waiting for him?
Oh, I'm waiting for him.
Okay.
I'm not